Okay, it says a second train B travels north from the origin station. So here's the origin station. They thought that was funny, origin station. Here's north. At time t, the velocity of train B is given by this formula. At time equal 2, train B is 400 meters north of the station. So here's train B. Find the rate in meters per minute at which the distance between train A and train B is changing at time equal 2. As I just sent out a text, made a mistake on this. I didn't include part C in this practice test because part C had an item that will not be tested this year. But in part C, they told us that the position of train A at time 2 was 300 meters east of the station. And you need that information to solve this problem. So here's train A, 300 meters east of the station. We're supposed to find the rate at which the distance between the two trains is changing. So they're giving a problem that they have given in previous years. We've actually practiced some like this earlier this year. They want the rate at which this distance changes. So think of this as, well, it's just a right triangle. So here's leg B, that's train B. Here's train A, and we'll conveniently call this distance C. We're trying to find dc dt. So this is a related rate problem. So I'm going to copy this over. And so we have, let's move some of this out of the way. Okay, so we can erase some of this. Okay, so it's a related rate problem. Let's see, dread. So Danica's chart, a mountain rate. So the amounts are the distances. The distance of train B, or you can really forget about it as being trains. It's just a triangle. And the triangle is growing because the trains are moving. One is going north, one is going east. Well, let's see, time equal 2. We have the table. So time equal 2, yes, train A is also going east because the velocity is positive. So really, the amounts are distance A, and then we have rate. That's dA dt, which is really the same thing as velocity A, the rate at which distance A changes. Then we have B, distance B, is the same as dB dt, which is really velocity B. We're looking for dc dt. So we've got this, and we're looking for dc dt. So we've got the Danica's chart, we've written down the rates we read about. We need an equation that involves our amounts. That's Pythagorean's theorem. So we have a squared plus b squared is c squared. Most of the time, better to not do any rearranging. Now we need to take the derivative of that equation. So it's going to be 2a dA dt plus 2b dB dt is equal to 2c dc dt. Awesome. We're trying to find dc dt, so now it's a matter of just plugging things in. Let's check our scoring guide. If we get that far, they'll give us 2 points for that equation that I just wrote. Now it's a matter of just plugging everything in. So we have 2 times A is 300. The ADT is how fast this distance is changing at time equal 2, which is the velocity of train A at time equal 2, which was given in the table as being 100. Look back here. Time 2, the velocity of train A is 100. So write in 100 plus 2 times B was 400. Now I have to know dB dt. Well, that's the velocity of train B at time equal 2. I need some more space here. So let's copy this over. And erase all of this. I was working on this equation. Let's see if this will move for me. Nope, it's going to grab that. We can grab this now. Move this down out of the way. Don't really need that anyway. Push that up there. Grab this. Okay. So I needed the velocity of train, I needed the dB/dt, the velocity of train B at time 2. I don't have to do any simplification. So I can just plug things in. Let's go look at our equation here. There it is. So I just have -5, 10. So I have -5, plug in 2, squared plus 60 times 2. The key thing here is you don't have to do all these computations. They just want you to show that you understand the calculus. Plus 25 close parenthesis. I was trying to solve for dc dt. So if I divide everything by 2c, this will all equal dc dt. Convenient line right there for me. So 2 times c. It's a Pythagorean triangle. 300, 400, 500. So, put a 500 right there. I've got that it all equals dc dt. Let's check the question one more time. That's what we're trying to find, is how fast that distance is changing. The units are meters per minute. Pull that out of the way. That's a good enough answer. Might want to have it say meters per minute somehow. So you might have to rewrite it, but that's one more point. You don't have to work it out. You don't have to simplify. They didn't actually require units because it didn't say including units. It actually gave the units already. So that would be a good answer for dc dt.